Hello, welcome back to the second part of Semantics for extra large banks. This is Jürgen. And if you remember in the first part, I spoke about the challenges for semantic centers of excellence and the vision semantic enterprise information architecture with the FIBO at the apex and derived data, object and message models. And I showed you like the source ontologies, the FIBO and OMG commons. And we looked at the financial industry business data model. How is it structured? How does it preserve the extensive FIBO OMG documentation? Now, in this second part, we will look at how the configurable ontology to data model transformation CODT achieves its results. And Atlantic was a nickname for the version, the first version that uses MS Excel Power Query and the M language. Yeah, the way to SEAI is model-driven development. And we have relational databases and now also semantic triple stores or RDF stores. And we have the industry standard, the FIBO in RDF OWL, and we always had data models that deploy on RDBMS. And with CODT, the configurable ontology to data model transformation, we have the sibling of the FIBO, FIBDM, as the conceptual data model. Yeah, and Atlantic is the way to semantic enterprise information architecture and model-driven development. So the FIBDM full version as of Q4 last year has over 3,000 entities. It's the world's largest data model. And Atlantic CODT, the configurable ontology to data model transformation, created FIBDM from the industry standard ontologies. So the patented technology that created the FIBO data model, and that's US patent 120.38939. And in the first part, we learned that the old OWL file parsing approach doesn't produce usable data models, and it cannot cope with very large ontologies like the FIBO. So the new ETL approach in CODT creates high-quality models. The technology is fully scalable and configurable. And what it is really is what we've done for 30 years. No? From the RDF OWL, it's ETL, extract, transform, load into the data modeling tool. Metadata sets are keyed records that hold properties for all objects in a model. So ontology metadata sets hold the record extracted from the ontology platform. Entity relationship metadata sets transform ontology into entity relationship representation. And PowerDesigner or other tools, metadata sets are ready to load into the data modeling tool. Yeah, and metadata sets are a radically different new approach. They are metadata stored in data sets. And that's similar to system tables on your relational database, not just like they store metadata about tables, columns, and foreign keys. So CODT metadata sets are isomorphic representations of ontology, entity relationship, and data modeling tool specific metadata. And then the transformation is a simple two-step process. So from the ontology metadata set, in step 1, we transform into generic entity relationship metadata sets. And then in the second step, we transform the generic ER into tool-specific metadata, like here for PowerDesigner. So the same generic ER metadata set is the source for both PowerDesigner and Spark's EA metadata sets. Yeah, let's look at CODT as a system. And this diagram here is a UML component diagram, and it is actually figure 2 of the CODT patent drawings. So in the box here, that's the configurable ontology to data model transformation, and it interfaces with two external systems, the ontology platform, that's an ontology editor, or it can be an RDF or triple store, and the data modeling tool, for example, PowerDesigner. And then here we have 3 core components: extraction, interfaces with the ontology platform, then we have a transformation, and finally we load into the data modeling tool. And MS Excel for version Atlantic is the tool of choice to view and analyze tabular data. And every data architect has Excel and knows how to use it. And therefore, MS Excel is a fast prototyping tool for the CODT metadata sets, and it makes it easy to deploy the transformation. And here this little table shows the components, the metadata set, and actually in CODT Atlantic they are different Excel workbooks for ontology, entity relationship, and for PowerDesigner. But any platform and programming language can implement the CODT system, the metadata sets, and the method. Yeah, from ontology class to data model entity, we follow the journey. And here on the top, we have the ontology MDS in Excel, and it shows us the classes tab. And at the bottom, we have the outcome, the PowerDesigner MDS for entities, and PowerDesigner can import directly this Excel spreadsheet. And then we will see how classes transform into entity code, and how the SCOS definition becomes the comment on an entity, and how the local name transforms to the entity name. Yeah, and the extraction works with SPARQL queries. So, and that is the novelty, no? So CODT doesn't parse RDF OWL files, but uses SPARQL to extract the ontology metadata. And here's an example query that selects the class, qualified name, namespace definition, and it is filtering out unnamed classes. No? So we don't need OWL nothing, and we don't need the OWL thing. And the result of that query is a CSV file. Yeah, so extraction loads the CSV result set into the ontology MDS. The ontology metadata workbook imports the raw extract and performs simple format conversions from the raw result. So we have here the class, we have the qualified name, the namespace, and the SCOS definition. And other tabs here would load on ontology metadata sets, now for superclasses, subclasses, equivalent classes, data, and object properties. Yeah, and throughout COD, Excel Power Queries extract into the metadata set. So here is our classes metadata set again, and we see here a comment from the comments ontology, authorization, code elements, code sets, classifiers, and so on. These are all ontology classes. And then if we do get data, it opens Excel Power Query ribbon. And the metadata sets are self-populated. So every worksheet has a query, no? And we see here the queries and connections for class, superclass, and subclasses. And we can refresh, meaning load individual or all metadata sets. And the queries and connection pane shows the load status, any errors, and the number of records in the metadata set. So, for example, here FIBO OMG has 2,436 classes. Yeah, and Excel Power Query makes the transformation rules very transparent. So here we have the Power Query editor, and on the left-hand side we see all the ontology metadata sets, and here for the class metadata sets, it shows us the steps, the transformation rules, and it gives us a preview of the result set. Yeah, and here it shows us the editor of the Power Query M language, and that's a 4GL language. And we see here the data source is the raw SPARQL query result set, and it would show us the code for the steps that it applies. Yeah, so transformation step 1 into the entity relationship MDS, and here we see the entity tab, and the code is populated from the class qualified name, and the URI, that is the uniform resource identifier of the FIBO class. And a VBA function transforms the local name into an entity name as per naming convention. So there's basically an uncaml, not changing the camel code into logical data model names, and you can configure that. So Power Query with the ontology MDS as a source populates the entity tab in the entity relationship MDS. Yeah, transformation step 2 into the tool-specific metadata set. So there we convert the generic ER into data modeling tool-specific metadata, in this case for PowerDesigner. And PowerDesigner can directly import this spreadsheet. So for entities, the transformation is a simple copy of the record in the ER metadata set. And then load in the data modeling tool. Here we have PowerDesigner, and PowerDesigner imports the metadata set. So here on the left-hand side, we see all the Excel imports defined in PowerDesigner, and we have 25 of them. And then we see the metadata set column mapping to PowerDesigner model objects. So stack queries and ETL master the complexity of the transformation. So we can see in MS Power Query the query dependencies. On the left-hand side, we have the ontology metadata sets, and on the right-hand side, the entity relationship metadata sets. and they are implemented into Excel workbooks. And for example, here, if we look at entity subtypes, we can see that this Excel worksheet is populated from the ontology metadata set for subclasses. And just a note here with here intermediate metadata sets. How we populate associative entities. Now, for example, in OMG Commons and in the FIBO, an object property can have an inverse property. For example, OMG Commons business authorizations would have authorized by and authorizes. Now, we don't want to have two associative entities in the data model, so we configure transformation rules to merge these two. And then we derive association subtypes from both the ontology object property and its inverse. Yeah, some statistics about COD Atlantic. So the MDS folders contains queries that provide the interface for metadata sets in the next transformation step. And we can see here, so the biggest piece is the entity relationship metadata sets, which has 80 tabs and 84 power queries. Then we see in total across the three COD workbooks, we have 142 worksheets and 158 power queries. And we have 18 SQL queries and 25 Excel imports into PowerDesigner. So COD is a white box, an open book. So in the Excel version, the software fully discloses all worksheets, queries, and VBA code. So new users and operators can generate with a single click using the default configuration settings. And as a data architect, you use COD as an ETL development platform, diagnosing results, tweaking transformation rules for your modeling and naming standards. Yeah, and if you want, VBA developers can secure the data sheets and fully automate the ETL. Or you can port COD to your ETL environment. Yeah, here we let's take a look at the COD embodiments. So here is the patent table 14, and the shaded area here in blue, that is Atlantic COD on MS Excel, no? And the license includes the patent rights to use the intellectual properties, to use the metadata sets and algorithm. For full production semantic enterprise information architecture, you can automate interfaces and encode the patent and embodiments below. So, for example, you can create a connection to your RDF store and run the queries in a batch. You can move COD server-side. You can migrate the ETL to your environment, or use your ETL language rather than M, and store the metadata sets on your relational database. Yeah, you can create a user interface for operators. You can create configuration wizards. And also you can generate other models like object models, message models, or physical models. And finally, you can load directly using your data modeling tool or model repository API. Yeah, the reverse mode means to transform your data models into RDF OWL to leverage your design of enterprise ontologies and knowledge graphs. And I said before, the CODT metadata sets are bidirectional. So no matter what direction we go, it's the same Excel tab. And with that, we can reverse engineer ontologies from data models. And again, it's ETL. Only here on the left-hand side, we have the data model. For example, in PowerDesigner, we extract, transform, load into our RDF store. And the first step is to generate list reports matching the data modeling tool-specific metadata sets. So Power Query populates the metadata sets, performing basic data cleansing. And then the tool-specific MDS populates the entity relationship metadata sets. And finally, the ontology metadata set populates from the entity relationship metadata sets. So Power Queries and formulas break the data set down into triples, and we load triples into the ontology platform using SPARQL construct or bulk insert. Yeah, and here's an example with a very simple model. And this is the New York Stock Exchange Open Mama messaging API. And here we see this data model has some tables for auction, order book, quotes, and trades. And the PowerDesigner entity list report has a code, name, and comment. And PowerDesigner MDS sources this list report. So we create this report here in the modeling tool, and then we load that result set into our PowerDesigner MDS. And then we transform the entity relationship MDS, and the metadata set here populates from the PowerDesigner entity MDS. And we see here then we have the same call use for the entity. Now we have a code, we have a name, comment, prefix, local name, URI. And these are prefix and URI are configuration settings matching the designated prefix and namespace in the ontology. So here, in other words, I tell CODT that I want to use this prefix here for my generated ontology. And the entity name transforms into a local name with a camel code string function. And also here from logical naming standard order space book, we get the camel code. And the resource name is simply a concatenation of prefix, the colon as a delimiter, and the local name. And then we can load into the ontology metadata set. And there we have already class, namespace, SCOS definition, and the other properties. And here, this helper sheet here, triple metadata set, it breaks down the class record set into triple subject, predicate, and object. Yeah, and the triple that we assert in the ontology actually match the SPARQL select joins. So up here we have triples that we want to construct, assert in the ontology, no? Subject, predicate, object, auction, its RDF type, and it is an OWL class. And that matches actually what we did to create 50M. No? We queried class, qualified name, namespace, and SCOS definition. And then the definition here is the same. No, here we want to construct CFIP OMDS security status, SCOS definition, and here's the definition text. Yeah, and finally we assert the triples on the ontology platform. So here we are in top rate, and we have several classes, and we have our SPARQL construct statement, and we see here the auction class with its SCOS definition. Yeah, the United States Patent and Trademark Office has granted the CODT patent and published it with its 20 drawings, 19 tables, and 35 pages of specification, which fully disclose the invention. And you can read up about the patent on the CODT.net website. And 16 claims comprehensively cover the method system and non-transitory storage medium and all embodiments. The patent protects CODT licensees and generated models, including 50M. About licensing CODT, 50M licensees can purchase CODT as an add-on, and new users can license CODT and 50M as a bundle. Now there is no standalone CODT license, and simply because JZit already holds the copyright to the FIBO data model. And software deliverables are the MS Excel CODT workbooks, and the license doesn't limit the number of users. You're free to modify the software and to create new models for internal use. Just like your 50M license, you must keep derived models confidential. So you cannot use CODT and publish your own 50M. Educational resources are included, and you are free to modify, translate, edit, lift off images and diagrams as long as it remains within your organization. And the license fully covers the intellectual property, the patent rights. So you're free to leverage metadata sets, queries, formulas, algorithms disclosed in the source code and the specification for internal development. But you must not share CODT embodiments outside your organization. Yeah, and just like it was for 50M, licenses are priced for institution size, and it started as per your EDM Council membership tier as a pricing segment. And so the add-on price for existing 50M licensees is 2/3 of the price of your data model license. So for example, around 40,000 for a tier B bank. The bundle price for new users is 1.5 times the standalone 50M. And just like with 50M central banks, multilateral lenders and other qualifying financial institutions get the tier C price irrespective of their asset size. Yeah, CODT proof of concept. That's an offer to try, test, and evaluate CODT. So the scope, semantic enterprise information architecture is quite a bit undertaking, And 50M already proves that CODT creates a superior data model. So then the objective for the POC is simply to show that code works for your fiber extensions, to test the application and to evaluate the intellectual property. The materials for the POC are the Excel workbooks, education material, and the patent for legal and compliance to assess. And it contains 2 days of training and 3 additional days of offline support, and emails and calls. So who should be in a POC team? Like management, finance, your business sponsor who's authorized to sign non-disclosure and license agreements. Here, importantly, the ontologist with an in-depth understanding of the FIBO and in-house ontologies, because you are the one responsible to adapt the queries to your SPARQL dialect. You produce the raw ontology metadata. And a data architect with experience in enterprise reference models. So you configure code to match your naming standards, and you load metadata sets into the modeling tool. And then the developer or MS Excel Power users with some experience in VBA, Power Query, and the M language. You can troubleshoot complex formulas and queries and explore other technical embodiments. Technical preparation for the POC. So you should have PowerPC. I recommend Windows 11 64-bit with some 32 GB of RAM, and MS Excel and Power Query, the data modeling tool, in interface to the RDF platform installed. And then you need the where you have the FIBO ontology, the platform or ontology editor with the SPARQL query user interface. And that can be TopRate, Protege, or any RDF store semantic endpoint. So you should use SAP PowerDesigner data modeling tool. If you have Irwin or other modeling tools, use the PowerDesigner trial first and import the data model. Later, you can customize code to import into your tool. And then you need the FIBO loaded into your ontology platform. So you should try entity queries and reproduce the raw metadata extract. Your proprietary ontology should be an extension of the FIBO. Make sure to include FIBO modules and to define a prefix for your namespace. And here, for example, is the bank ontology, and so there then we just have another TTL turtle file. The entity query must return FIBO alongside your classes with the prefix. So this all means your FIBO extension or other in-house ontologies must be well formed. Proof of concept typically would take 6 weeks. So we have 2 weeks for introduction into COD and transforming the FIBO as a POC. And then we repeat that exercise, adding your proprietary ontologies. And you can explore configuration changes and other embodiments. Next step, if you want to discuss a COD POC, you find further resources on the 50M and COD websites and on the this video on the YouTube education channel. And you're welcome to send me an email to schedule an overview and discussions with your questions and answers. In summary and conclusion, the semantic center of excellence must not become another silo. Our vision is semantic enterprise information architecture with the ontology at the apex. FIBO is the industry standard, and 50M is the superior industry standard data model. COD leverages the ontology for data management, and copyrights and patents protect your investment. Well, thanks for watching.